let's talk about this. So what's the only way, Nathan Nelson, you can generate a pH greater than 7?
A lot of OH products.
Yeah, you had to produce hydroxide ion, right? So it's an aqueous, so you have added water to it. I never want to see that again.
Bro's venom, bro. Yeah, because he's
Gavin's got it in me, I'm sorry. Gavin's got it in me, I'm sorry. I spend too much time with him per day.
Stop!
Lunch. I know, I need to stop.
What did you do?
Don't ask. I will never speak it again. So, which one of those 3 compounds has an anion that's the conjugate base off of a weak acid?
Na2CO3.
Yeah.
Na2CO3, because that's hydrochloric acid, that's sulfuric acid, so none of those will. So the only one that can make the pH go up is going to be the sodium carbonate. Go with that. Will Stanley, sodium carbonate soluble.
Yes.
Why?
Because it dissolved and created the higher
Group
pH.
1.
L.
Also, yeah, group 1 element.
Sodium is group 1.
I know
So,
that one. I know that one.
Potassium chloride is going to be soluble. Sodium sulfate is going to be soluble. Now, then you've got evolution of a gas. Okay? So if you look at this, the only gas you can reasonably produce is going to be carbon dioxide.
Yeah, that's what I did.
Okay? You're not going to produce chlorine gas because it doesn't like being that form. It wants to form a chloride ion. Sulfate is just weird. So the carbonate's the only one that's going to produce anything. So based upon that, what do you have as compound X?
Sodium carbonate.
Sodium carbonate. What do you have as compound Y?
Potassium chloride.
Potassium chloride, and then you have magnesium sulfate. So X is the sodium carbonate, Y is potassium chloride, Z is the magnesium sulfate.
And in part C, that's where you get the OH minus the carbonate.
Now, on part B, it says write the chemical formula for precipitate produced when sodium hydroxide is added. Now again, I don't care what you have as your compound Z, but here's the story. So let's say, for example, you think C was potassium chloride. Let's say that's what you think Z is. Okay? Now, if you add sodium hydroxide to that, you're going to make sodium chloride and potassium hydroxide. Are either one of those going to be a precipitate? No, because they're both group 1. So if you had, this is what I'm telling you in terms of the logic process, if you had Z wrongly as potassium chloride, you can't make a precipitate out of that. So the only one that can make a precipitate is the formation of that magnesium hydroxide. So your answer to B is magnesium hydroxide. Now, the Nathan question, question C, where it says, explain why an aqueous solution of compound X is a pH value greater than 7, and write an equation.
Hey, I had an equation.
Not an equation.
Well, I mean, it's happened. Yeah.
No, it's not. It's not even
I just
close.
want you to think
It's about a quarter.
So, you need to have like carbonate ions reacting with water to reform carbonic acid
Yeah.
and hydroxide ions. Okay? And then it says the explanation is, hey, I generated hydroxide ions and that raised the pH. Now, on D, here's a subtle part to D, and this is dealing with dilution. So this is like general lab knowledge. So when you do dilutions, you can either generally dilute acids, or you can dilute bases. So here's the story with acids. If you're diluting an acid, you add the acid to the water.
Always add acid.
Okay? Now, if it's a base, you reverse it. You add water to the base. So I always remember this in terms of like the alphabet, A comes before B. So if it's an acid, you add the acid to the water. The reason that happens is because a lot of times when you dilute an acid, you break a lot of bonds, which releases a tremendous amount of energy, and you want the water there to absorb that energy. That's why you do that. So that's what's going to be a subtle part on part D. So you have a burette, which you all have used, you know, the burette that have the valve at the bottom, okay? So you need to start off by using M1 V1 equaling M2 V2.
33 milliliters.
You need 33 milliliters of your base. So you would use your burette to measure out the 33 milliliters of your sodium hydroxide. Now, you'd put that in the flask. Then you would add the water to the base. That was one of the points of emphasis when they graded this. Did the kids say to add the base to the water? Did they have that sequence correct?
You mean water to the base?
Yeah, water to the base. You'd add the water to the base. So that was one of the key points. All right. Now, the 100-meter volumetric flask, that's those, looks like a round bottom flask, but it has a mark up there on the neck. These are one-trick ponies, but they're only used for measuring out one specific quantity of 100 milliliters. Okay. So, on E, calcium carbonate versus sodium carbonate. One option is that you look at solubility. Now, does anybody know the more common name for calcium carbonate?
Baking soda.
Limestone. Or baking soda.
Come on. I saw it, baby. Hey, where's it at?
No.
Hey,
So, how do you know that calcium carbonate is not soluble in
Because when
water
it rains, the K-State doesn't fall down.
or K-2? Okay? You wouldn't
No.
build buildings out of soluble blocks.
What
Okay?
about a mud hut?
Now, another option is that you could do a flame test.
The flame test the code.
Wait, what
Okay.
if you just add HCl?
What, and then do what?
Gas versus no gas.
No, because they both contain carbonates.
So,
No. So,
breathe it in. You die.
here's the story. So, sodium is, anybody know the color of a flame test for sodium?
Yellow. Yellow.
And yellow is
It's
orange, yeah.
Oh,
Okay. And
What?
calcium is
Red.
red.
Wait,
Why?
I thought that was licking.
So you can do a flame test. Sodium would be orangish, yellow, and the calcium carbonate would be have a reddish color to it. Okay, let's call it a night.
All right.
Maybe.
Finally go on.